Hello guys, my name is Redis Cache and this is an introduction to Redis. Now in this video we will talk about what a distributed cache is, and Redis is a distributed cache. We will see how to implement it in our ASP.NET application, and in the next one we'll see how we can use it very easy with Mediator, taking advantages of Mediator's behaviors. So first of all, let's see what do I have here. I have a Heroes API. I have a simple controller with one endpoint. In that controller I inject a hero repository, and we have the get endpoint with a route parameter named ID. We get that ID, we try to get a hero from our repository based on that ID, and then we return OK with the hero. Now I have a fake implementation of a hero repository. I have a read-only list of heroes, and that could also be static, but it's okay. And in our get method, we accept the ID, we wait for half a second to simulate a database call, and it's half a second for visualize purposes, and then we get the hero from our list based on that ID. So let me run it really fast, and I'll also open Postman, and if I make a call with the ID of 1, I'll get back after half a second the hero with the ID of 1 and name Spider-Man. Okay, very simple. So let's see how our application works as it is. We have our user. It makes the call with the ID to our application. Our application makes a query to the database with that ID to get back the hero. It retrieves the hero and sends it back to our user. Now we made a business decision and we said, look, our heroes never change, and even if they change and the user gets back a hero that has changed, it's not a big deal. So we will use cache so our responses will be faster and our user can have a better user experience. So we can use ASP's .NET default cache, and that would look something like that. So our user will make that request with the ID. Our app will make the query to the database. It will get back the hero from the database, and now we'll store in memory that hero, and then we'll return it back to the user. So the next time a user calls our API with the same ID, our application will check in the cache, and remember that's inside the memory of the application. And if it finds the hero with the same ID, it won't go to the database, but it will return immediately the hero from that cache. So we saved resources, and the user had a faster response since we avoided that call to the database. So why don't we use that and we want to use Redis? Let's say, for example, that we have multiple instances of our application running, two in that diagram. As you can see, we have instance 1 and instance 2. So a user makes a call with an ID. Our app goes to the database, retrieves that hero, saves it to the cache, and sends back the hero. Now we have another request with the same ID, but that time that request lands to our second instance. So although we have seen that hero before and we have stored it, since that cache is in memory, the second instance doesn't know anything about the other instance. So it will go again to the database, it will retrieve the hero, it will store it to its own in-memory cache, and it will send it back to the user. So not only the user waited more than it should, since we have already cached that hero, but now we have the same hero cached twice, and it could also be saved 3 times or 4 times depending on how many instances we have. So not only it's bad from the user perspective, but it's bad from our perspective, since we increase a lot the memory that our application needs. And that's where a distributed cache comes into play. So we remove the in-memory cache, and we have a different service possible for the caching outside of our application. In here, as you can see. So now all our application's instances talk to that same cache instance. So if I make a call with an ID, I will get that from the database, I will take that and I will put it in that external cache storage. I will return that back to the hero. Now if I have a request with same ID to any other instance of our app, let's say in instance 2, for example, I will take the request and I will go to my cache. I will see if that hero exists here, and if it exists, I will return it back to the user without the need of going to the database. So what we basically did is we removed the cache from inside of its application instance, and we put it somewhere else so all our application can talk to that same cache. So enough with theory, let's go and implement that with Redis in our application. First of all, I will need to add a nugget packages. I will search for microsoft.extensions.caching.stackexchange Redis. I will add that to my project. And before we get started with the code, we need to have a Redis instance running, and we can use that with a Docker image. So all you need to do, let me copy and paste that command for you, is to say docker.run, specify the port and a name for our Redis. I will call that heroes Redis, and that will download the latest image and run it. So I have mine already up and running, so let's go and do some configuration first. All we need to do is say builder.services.add stack exchange Redis cache, and in here we need to pass some options or an action that will create that options, if you will. So I will say, let's say options, and we'll say options.configuration, and then in the configuration actually we need to pass the connection string, and since it runs locally we will say localhost, and the port is 6379, and that's all we need to do. We can also specify an instance name, and we will see in a bit about that. I'll leave it empty for now. So now I'll go back to my heroes controller, and I'll inject a distributed cache service that comes from that NuGet package we just installed. So I'll say private read only I distributed cache. I will name that distributed cache. And now let's say that we have our first request, so we get our hero from our repository. So before we return it back, we need to save that to our cache. So we will await, since we will have an asynchronous call, we will say distributed cache.setString async. And now there are 4 if you count the cancellation token. First is the key of that value we need to store, second is the value, third is some options in which we can specify how long we need that to be cached, and the cancellation token. So first of all, for the key, I'm going to say var cache key equals with, and in here I could pass just the ID, but maybe instead of heroes we need to also cache some villains, so we can't have just the ID, because a hero can have the same ID with a villain, since they are different entities. So I'm going to say heroes underscore and then the ID, so hero.id, and now we'll pass that cache key. For the value we need since we store it as a string, we need to serialize that, so we'll say JSON serializer dot serialize, and we will pass that hero. And for the distributed cache entry option, we will say new distributed cache entry options, and now we'll specify the absolute expiration relative to now. So let's say, for example, that we need to leave for 5 seconds. We will say time span dot from seconds. So from seconds, and let's say 5, and finally the cancellation token. Okay, so now we set it to our cache and we returned it to the user. So now we have another request coming, and we need to check if we have a hero with that ID in our cache, so we don't go to our hero repository. So we'll say var cast hero, and we will try to get a value from our cache. So, and let me fix the typo. So cast hero, say distributed cache dot get string async, and we need to pass the cache key. So we know that would be heroes underscore and that ID we accepted, and let's pass the cancellation token as well. So now we need to see if we get a value, so we will say if string dot is null or empty, we will pass the cast here and we will negate that, and we need also to await that. Okay, so if that string is not null, we mean we have a value for that ID. So we need to deserialize that to a hero and send it back. So I'll just say return, okay, JSON serializer dot deserialize to hero, and I'll pass that cast hero, and everything should work fine. So let's put a breakpoint and test that. But before we do that, let me tell you about that instance name. Let's say that you have multiple applications talking to the same cache, not multiple instances of the same application, but completely different applications. So we have, let's say, another application that also stores something related to heroes, and that's all, and has the same key, heroes underscore and the ID of a hero. Now if they both try to store, let's say, heroes underscore 2, that couldn't be possible. We will have a duplicate key. So if that's the case, we specify an instance name, so that instance name will be part of the key, and it will make sure that we don't have duplicate keys. Now since we have only one app talking to that cache, I'll comment it out, but I wanted to mention it so that you know what that is. So now let's test our application. Actually, let me make that to 20 seconds. So I'll run my application, I'll open Postman, and I'll make the request. So we try to get the cast hero, but since it's our first request, we don't have one. So we'll get that from our repository, and then now we will save that to our cache, and we will return that hero back, and we have it, as you can see. And now let's try that again. And that time, as you can see, we have our cast hero, and we will just return from here, and we will save the trip to the database. So we get that hero back. Now if we try with the hero, with the second hero, as you can see the first time, oh, let me remove that breakpoint, and actually let's do that with the third one. So it took half a second to get back Superman, but now it's cast. So if I hit that again, 4 milliseconds, 6 milliseconds, 4 milliseconds, and now since 20 seconds passed from when we saved Spider-Man to our cache, if we try to get that back, as you can see, it will take again half a second, but now it's cast again, and then it only takes now 4 milliseconds. So probably you won't extract that caching logic and have it in a different service, let's say, and also you don't want to call that service in each part of your application that you use caching. Maybe you want to have it only in one place, and that's what we're going to do to the next video. We'll use mediator's behavior for that, and the custom attribute to decorate our queries that has to do with caching, so we can have all that logic only in one place. But I think that was enough for today. If you like this video, please like and subscribe. Thank you for watching, and have a nice one.